In this demo video, we're going to try something interesting. We're going to run a program compiled for Windows on an IBM Power server. Normally, if we have a server with, say, an Intel CPU in it, we can easily install Windows onto it and then run any Windows application we want. This isn't a big deal. However, if we replace the Wintel server with an IBM Power server running SUSE Linux, our Windows app will no longer run. This happens for two reasons. First, Windows apps are compiled using a particular instruction set or machine language called x86. Because of this, these apps can generally only be run on computers that understand this language. Computers with Intel or AMD CPUs, for example. Our server has a CPU using the Power architecture, so it doesn't understand this language. To get around this, we're going to use IBM's Lx86 extensions. Lx86 is free software available on IBM's website that dynamically translates x86 instructions into Power instructions. This is going to let us run programs compiled for x86 Linux with our server running Linux on Power. The second problem is that the Windows app makes system calls that are specific to Windows. For example, system calls the app makes to draw or resize the window, open a file, and so forth, are made using functions that are specific to Windows. Linux won't understand them. We'll work around this issue by using a translation layer called Wine. Wine is an open-source x86 Linux program that maps Windows system calls to Linux calls. People generally use Wine to run Windows-only productivity apps on their Linux machines, like Outlook or Internet Explorer. We'll use it in concert with Lx86 to run a Windows app on a Power-based Linux server. Before we go any further, I should note that, to my knowledge, IBM doesn't officially support using Wine to run Windows apps on their hardware. This is just something we're trying for fun. Now, let's get started. This is a SUSE Linux Enterprise desktop running in a logical partition on a Power 550 server. I have a monitor up showing the Linux LPAR running alongside a virtual I/O server on the same system. We'll get to the VIOS partition in a bit. Let's start by running the run x86 command to activate the Lx86 environment. Now, any x86-based Linux programs I run from here will behave as if they're running on an x86 machine. We're going to run Wine from inside this environment, but what Windows program should we run with it? Let's go into my Wine directory and see what we have. There's a directory here pretending to be a Windows drive, and I've got a couple of apps here, including Pinball, so let's run that. Pinball is something you can find on pretty much any Windows machine right there next to Solitaire and Minesweeper. I'm passing Pinball in as a parameter to Wine. There's a short delay here while Lx86 crunches on the initial batch of instructions. And here we go. Let's move the window a bit out of the way here. If the video seems a bit jerky, it's because I'm running this through a VNC remote desktop session. So that's introducing some network lag that slows things down. As you can see, despite the two levels of dynamic translation and the network lag induced by the remote desktop session, this game is still pretty playable. This is nice, but what else can we do? The Power server I'm using can actually transfer a running logical partition from itself to another server on the same network, without stopping execution on the partition. And I just happen to have another server handy. Looks like this server already has an AIX LPAR on it, but there's plenty of room here to move the Linux LPAR to it. We do this from the HMC interface. Let's bring it up. From here, we can select the LPAR, then go through the options to start a mobility validation operation on it. Among other things, the validation is checking to make sure the LPAR is using only virtualized I/O devices. This is where the VIOS partitions come in. As long as the LPAR runs all its I/O requests through virtual devices owned by the VIOS, and as long as there is a VIOS running on both systems, the LPAR's I/O handles should transfer over to the new system without a problem. Once that's done, we just click Migrate to start the migration operation. This happens in the background, and we can continue to play Pinball while it's happening. It takes a little over a minute to complete, but we'll speed things up a bit here so you don't have to wait. Notice the VIOS activity. The VIOS is transferring the live memory state of the partition between the two systems. There it is. We've just switched our execution over to the other server. Notice that Pinball still plays just fine. It, along with the Wine and Lx86 environments and the remote session, moved over right along with the Linux OS partition. Thanks for your attention. This concludes the demo.